So now we're going to try and solve an angled projectile problem. All they give us is that our ball is launched at 4.5 meters per second at 66 degrees above the horizontal. And then they say what are the x and y components of the initial velocity. So what I'm going to do is I'm going to draw my my example. Just so you can get an idea. And I know that it goes as a curve, but we're going to kind of simplify it a little bit with basically two right triangles. And so this right here is 4.5 meters per second. We need to find our Vx. We need to find our VFY. And we know, well, we need to find, our initial VFY. We know our final VFY is equal to 0 because just like we did when we were doing free fall problems, at the very top it stops for a second, at least vertically, and then goes back down. And we know that this angle is 66 degrees. So the first thing we need to do is find the x and y components. Now to find the y component, we will use that formula AY is equal to A sine theta. So my VIY is equal to my velocity times sine theta. My velocity, my vector velocity is 4.5 meters per second, and my sine of 66 degrees. To find my Vx, we're going to use this formula. Ax is equal to A cosine theta. So my Vx is equal to 4.5 meters per second, because that's my vector velocity, times the cosine of 66 degrees. Now, since we're using cosines and sines, remember you have to have a calculator that is in degrees. It cannot be in radians. When you put this in your calculator, you should get 4.1 meters per second for your initial y velocity, and for your x velocity, which is both your initial and your final because it's not accelerating, is going to be 1.83 meters per second. And that's how we find our x and y components, which we will need those to do any more math. So this is part B. We had 4.5 meters per second was this hypotenuse. We had 1.83 meters per second was our Vx, and 4.1 meters per second was our initial Vx, or our Vy, our initial Vy. So now we want to solve for the total time the ball is in the air. So to solve for time, I can't use the one we used for the horizontal projectile problem because they gave us a height and we don't have a height. And again, this one uses the height, so we can't use that one. And this one is only for Vx, and that gives us a horizontal distance. We need the horizontal distance in order to find the time. So this top one is the only one that we can use. Okay, so it says that VFY is equal to VIY plus GT. We know our final y velocity is 0 because at that very top part right here, our VFY is equal to 0. Our initial y velocity is 4.1 meters per second. And then because we're moving up in this section, but gravity is pulling down. We need to make gravity negative. And then we have time. The first thing I'm going to do is I'm going to minus 4.1 meters per second from both sides, or subtract it. That way I can get try and get t by himself. So I have 4.1 meters per second equals negative 9.8 meters per second squared times time. I'm going to divide both sides by negative 9.8 meters per second squared. Again, this is my goal of getting t by himself. When I do that, my meters will cross out, 1 second will cross out, and this squared will cross out. And these negatives will become a positive. And I will end up with 0.42 seconds equals t. Now remember, this is only half of the t. This is the t for this part. So if I want to find the total t, I need to take that 0.42 seconds and multiply it by 2 in order to get my total air time, which is 0.84 seconds. Now for this last one, we want the maximum height reached by the ball. So I've written everything that we know over here. I've drawn our triangle and I've written our formulas. Now in order to find the max height, we need to use a formula that has a height. So this one does not have a height and this one does not have a height. These two both have heights, but in this one we've already solved for the height, and so this one requires less algebra, so I want to use this one. So our height is equal to VIY times t plus 1/2 g t squared. Now in this one, we're going to use our half time because the max height occurs at the end of this half time. And so I don't want the full time, I just want the half one that I solved for, which I have over here. So my initial y velocity is 4.1 meters per second. My time is 0.42 seconds. My gravity is going to be negative 9.8, and this is because we're going up. And so gravity is acting in the opposite direction. And so we're going to have gravity be negative. 4.1, times 0.42 is going to be 1.72 meters. 1/2 times negative 9.8 is 4.9 meters per second squared. 0.42 seconds squared is going to be 0.1764 seconds squared. These seconds will cross out, so you'll have 1.72 meters minus 0.86 meters, which is equal to 0.86 meters. And so this is the max height that your ball will reach. And now we've solved all the little bits of an angled projectile problem.